All right, folks. Indirect measurement. Let's look at this. Indirect measurement is any measurement, that uses formulas, similar figures, and or proportions to measure an object. This is a little bit of, close enough, far enough away. This is close enough. I would. Yeah, I got you back on that. Here we go. We've already done this a little bit last week, so it's pretty simple. Remember the picture with the guy standing up? It gave the measurement. It was on your quiz on Friday. The guy standing up, it has his height. It has the shadow. It was the girl. She was looking up in the tree with the bird. Yes, with the arms. Yes, she had the cute little dress on and had the bird in the tree, remember? With no arms. Don't be hating on her. We love her anyway. Exactly. Maybe she was standing like this. Maybe she had no sleeves in her dress, and she had her arms crossed in front of her, and you just didn't know it. Don't be hating on that picture, y'all.
I think I am.
Shut your face, or I will shoot you in the forehead with a Q-tip. Now, here we go. It says, whenever dimensions are given in both feet and inches, you've got to convert from either inches and or feet. It has to be one dimension or the other. You cannot have two different units of measurement, okay? Now, this is very simple. Now, I want you to look at this because in our textbook, it can be very tricky if you're not looking at this correctly. It says, Tyler wants to find the height of the telephone pole. Folks, if we had time, and we had plenty of time to go before the SOL, then we could go outside on a sunny day like this, measure our shadow, and measure the height of the poles, the light poles outside. But we don't have time to do that, so sucks for us. So we're going to do these cool problems on paper. Yes! So here we go. It says he measured the pole's shadow and his own shadow and then made a diagram. What's the height of the pole? Surveyors do this every day, okay? Now, what's going to be the problem with this? The 5 feet 9 inches. This is not 5.9. Oh, you're going to convert everything to inches. You can totally do that. That would be the easiest thing to do. Now, how do you know that his height is 69 inches tall? All right, so let's make some conversions. Okay, this is 2/18. Be sure you put the day's date on the top of your notes. Okay, so let's convert 5 feet 9 inches to just all inches. We got to do a little prep work before we start figuring out how tall this light pole is. Joseph, you said take 12, multiply it by the 5 feet, which is now 60 inches plus 9 inches, which is, what y'all? 69 inches. We have to do the same thing for 7 feet 8 inches and 38 feet 4 inches. 7 times 12 is 84, which gives us 92 inches, guys. Is that right? You with me? Or are you just copying what I'm putting up there? Or both? Does it make sense? Okay. And then, of course, we have to go with the other one. Yes, ma'am. This one's going to be a big number. What's 38 times 12? 456 plus 4, which is 460 inches, yes? We have a bunch of interruptions. 460 inches, yes? Okay. Now, am I ready to set this proportion up? This part's the easy part. Though this is the very tedious part. Takes us into a lot of details, okay? But if we get ready and we're going to set up our proportion, come on now, move over here. Then how am I going to set this up? Remember, oh, hold up. In similar polygons, corresponding angles are what? Congruent, and corresponding sides are proportional. Now, that being said, what over what? 92 over 460. And so Joseph's getting us started. What's his guide that he's using? Little over big. That's his guide, little over big. So if he uses 92 over 460, then what number does he have to have in the numerator of his second ratio? 69 over what? H, right? All right. Oh my, I don't know what to do. Do the same thing we've been doing for a week, right? Go for it. Go. Figure this one out. Good for you. Bless you. Your final, this answer that you get will be in inches, in terms of inches. All right, what is 460 times 69? 31,740. Is that what you said? Okay. Divide both sides by 92. And how many? 345 what? Inches. Now, is that acceptable? That is acceptable because it is correct. However, if I were to change this back into feet, it would be a better answer. Okay? Now, I think of going old school with this. Because I go 12, and look, I'm doing old school division. How many times is 12 going to 345? Take your calculators. Oh, wait. 12 goes into 34 2 times. That's 24. That's 105. 12 times 10, 9. 9, it goes 8. 96, right? Which is going to be 9 left over. No, I could, but that's going to give me a decimal. I don't want a decimal. Look at what it gives me. This is 28 feet. What's 9 over 12? And 9 inches. The remainder is how many inches you have left over. Okay? This is old, long division. What other way would you do it? Would you go 28 3/4? Is that what you're thinking? I would. If you put it in the calculator, you're going to get a decimal. And see, that's why if you go old school, it won't give you a decimal, and you'll know immediately whatever's left over. See, because in your calculator, it's going to give you 0.75. Do you know 0.75 is 9 inches of a foot? No, we're not going to round. And you know why I'm not going to round? Look at the original problem. The original problem had 7 feet 8 inches, 5 feet 9 inches, 38 4 inches. Okay, so if it's in terms like that, I want to take my answer back to what it looked like in the very beginning. Okay. Okay, but don't know that everybody's going to think to do that. I would just go old school and see what you come up with. Let's see, you guys have the TIs, right? The Texas Instrument calculators? All right, let's look at what it would look like from your perspective. Say what? All right, check this out. Here we go. This is what you will see. Excuse me, ladies and gentlemen. This is what you will see with your calculator, okay? So we've got 345 divided by 12. All right, I cannot have 28.75. So what I would do at this point is I would go, okay, old school, 12 into 345. I know it goes 28 times. I have to take into account, if I don't know immediately that 0.75 represents 9 inches of the 12, then I would go 28 times 12 is 336. And then I would subtract that, and I would get my remainder of 9, which means, hello again, 28 feet and 9 inches. In the calculator, that's the way I can get around doing long division. Okay? But I have to physically see the remainder. I don't know why, because that's just the way my brain works. Okay? But that's what you're going to end up doing. If you start with feet and inches, your answer should be in feet and inches, okay? That is like leaving an answer as 2/4 and not reducing. You must simplify. It's just going to be, I mean, who's going to give you 100 pennies as your change? So think about it. Are you ever going to go to a store and they're going to give you 100 pennies back? Well, if they don't have any money left, maybe, or they didn't like you. Let's try this one. Hey, do this one yourself. What? Wow. That's pretty cool. Hey, do this one yourself. Come on now. All right, here we go. So, if you see 5 feet 6 inches, then that means you need to convert every measurement to inches. So, five feet times 12 is 60 inches. That would be 60, how many? 66 inches. What's 14 times 12? That's 144 plus 28, it's 160 something. Plus 2, which is 170 inches. Did everybody at least get your conversions correct? One of them? Do you know what to do now? You got to, at some point, get this. Now, how would I set up my proportion? No, and it's not going to give you the right answer. Because if you convert one, you got to convert all of them. Okay? Got to convert them all. The last one over there, the big shadow is 170 inches. Set this up for me, please. Go, Kevin, set it up. 66 over X. Oh, what's his guide? Somebody else, what's his guide? What thing over thing? Because you're thinking along the right thing. What is it? Look at it again. Height over what? Oh. Oh. Who gave me this? The 66 over X. Kevin, he's got all of his height in one ratio, and then he's going to have all of his shadow in another one. I can do that. No, that's not bad. That's just a different way to look at it. That's fine. So if he has the height of the man over the height of the pole, it's going to be equal to 60 over 170. So he has, the guide is, no, he's got the height in the shadow, the left and the right, but then he has the man's information here and the flag information here. This is when it kind of gets, you got to make sure everything goes with the right place, okay? With the man, I've got the 66 inches, the 60 inches. That all comes from that picture. The flag information is the X and 170, so that's safe. This is like a two-way check on this problem.
Could you do like 66 over 60, X over 170?
Can I do that? Do I like for you to do that? I don't like for you to do that because you got to do corresponding sides. 66 over X? That's what he did. What did you say? 66 over what? X over 66. And you got your X right there. 66X, then what do you have on the bottom? 60 over 170. Is it going to work? Yeah, it is. Because look, 60 times X, 60 times X. It's going to work. However, why is it going to work? No, not corresponding. You're in the right family, but the wrong word. You're warmer. No, not congruent. Corresponding is the right word, but it's in the right family, but it's not the right word. Corresponding, proportional. No. What kind of, do you see? Thank you very much, atta girl. We're dealing with similar triangles, folks. That's why I can set it up the way you want to set it up, and it will work. Because these two triangles are similar. That is exactly why. It definitely could work. But, hold up. You need to make sure, no matter what you have, that you are going to multiply 60 times X. Now look at your problem and see if that's what's going to happen. If you have 60 times X, that's 60X. What is 66 times 170? Divide both sides by 60. 187 what? Inches. Good. Now, is that the way I want to leave my answer? No, this is when I take my calculator. Dang it. Let's try 11. Because I messed up. Because it's 15. Sorry, thanks. So it's 15 feet, 7 inches. How many of you had that? Hands up one more time. Okay, thank you for calling me on that. Just had a brain fart. Thanks, it does happen. And it's Monday. And I just got here at 10:30 today, so, or 11:30. My daughter was sick. Okay? Daughter. This has been, you know what? I was thinking. All right. Represents an object as blank than or larger than, smaller than or larger than its actual size. Okay? The drawing scale is the ratio of any length in the drawing to the corresponding. That's right. Corresponding is important to us, okay? Ratio is just a fancy word for what? Fraction. Good. Scale drawings. We've already done these too. For example, and we've looked at these problems, if you have a map that says 1 centimeter is equivalent to 1,500 meters, that's a scale, okay? And it can help us compare measurements that have different units. Now, look at this. Now, some of you will totally go common sense on this. I don't do that. I have to do the math. It says on a Wisconsin road map, Kristen measured a distance of 11 1/8 inches from Madison to Wausau. The scale of this map is, this is important, 1 inch to 13 miles. This is literally in the form of a ratio, okay? I want to change it to a fraction because I like fractions. Fractions are our friends. What's the actual distance between Madison and Wausau to the nearest mile? What's the only other number I'm given? 11 1/8. Now, calculator. Get your calculator. Take your calculator. I know what 11 is. 11 is 11. But if you didn't know that 1/8 was 0.125, how would I determine that? Just divide 1 by 8. And hey, 0.125. Now I'm going to take 11 and we're going to change 11.125 inches. Where does 11.125 go? Why? Because the inches are on top. So I've got 11.125 and I want to find the nearest mile, folks. How can I do that? Cross multiply. 1 times x is x. 13 times 11.125. It's too many people talking. 625. All right, think about what that means. 144.625 what? Miles. I would leave it. Because, why would I leave this as a decimal? It is what it is. Thank you. Oh, why? Think about driving. How many of you driving now? You're on the road. Okay. Legally. How many of us driving legally? Okay. All right, think about it. Can you drive 0.625 miles?
Yes, because it's a mile and 10.
No. When I'm checking the odometer, won't it have sometimes 0.625?
Yes.
Or 0.7, and that'll just keep tripping until you get to 1 mile, right? So it's okay to have this as a decimal because we're talking about miles. It's not okay for inches, feet, any linear measurement. That's not okay to have decimals. We don't measure with a ruler. Wait, it's 0.75. No, there's no ruler that looks like that. Okay? Questions on this? Fossil or difficile? Fossil. Let's look at the next one. Lady Liberty, who is that? Statue of Liberty. Holds a tablet in her left hand. The tablet is 7.19 meters long and 4.14 meters wide. If you made a scale drawing using the scale 1 centimeter to 0.75 meters, what would be the dimensions to the nearest tenth? Now, I'm going to just tell you right now that maybe she is holding the original iPad. Just think about it. Didn't you say iPad? It's the original iPad, Joseph. Who would have thunk it? Hey, here's the thing, folks. You have 2 dimensions, okay? You have length by width. So we're going to have to do 2 different calculations, okay? We have to determine the length, and we have to use the scale that we're given, okay? We have to use 1 centimeter to 0.75 meters. What is the length given of that tablet, of that original iPad? Okay, here's our length. That means that 4.14 has to be our width. Okay, we're going to use that number in a minute. Where will I put 7.19 meters? Why on the bottom? Because it's meters, Miss Perry. Nope, nope, nope. Remember, I got to find the length first. Right, because I would have a different, and I don't want that. Folks, I don't even care about meters right now. I care about solving for the number of centimeters, okay? Yep. We're going to deal with that in just a minute. All we're concerned about right now is just the length of this tablet, okay? When you're given the dimensions, I have to take care of the length first, and then I'll go back and I'll take care of the width, okay? All right, so what is 7.19 divided by 0.75? Ooh, 958, so let's round it to the nearest tenth. 9.6. Why would that be centimeters and not meters? Because that's the scale. It's centimeters. Remember, you're making your scale drawing, and that's going to be smaller than the actual figure, okay? That is the length of the tablet. Right, and that is the guide we use. Now we have to figure out the width. I have to use the same scale, 1 centimeter over 0.75 meters. Were we given the width? Oh, look at it now. It's 4.14 meters. Does it go on the top or the bottom? It goes on the bottom because it's meters. And I have to put the meters on the bottom. You said it the other way. You said it that way? I heard it the other way. My fault. Okay. Figure out what this is. No. This is correct. Now you figure out this. What is 4.14 divided by 0.75? 5.52, which would round to approximately 5.5 centimeters, wouldn't it? Okay. So we have found the dimensions, the length and the width of this tablet, correct? Yeah. What did we just find? I don't know. We just found the width, but we found the length and the width of the actual tablet or the scale drawing of the tablet. The scale drawing of the tablet. Whenever you're given 2 dimensions, folks, you got to do 2 separate problems in one, okay? So be prepared to do that. I promise you're going to do that again. Questions? Because of what? See how the X is up here with centimeters? So my final answer has to be in centimeters, okay? Rectangular central chamber of the Lincoln Memorial is 74 feet long, 60 feet wide. Make a scale drawing of the floor of the chamber using a scale of 1 inch is 20 feet. You are finding the dimensions again. 2 problems in one. Go ahead, Zoe. Take charge. Ha. All right, talk to us. The scale is 20 feet, okay? What is she finding first, the length or the width? Okay, keep going. No, she just did. .7 what? It's inches, okay, approximately. Okay. So she found the length. How many of you got approximately 3.7 inches for the length? Hands up. Very good, very good. So you copied. Oh, it looks like we got 3 inches for the 60 feet. 3 inches wide, right? How many of you got 3.7 by 3? Rock on. Do you have questions at all? All right, so what are we doing? The last example, we're not doing that. We don't need to, because if you can do one problem, then you can do 2 more the very same way. We are getting ready to work on work. And then work. You guys are always good, but you don't like to work very much. Is that correct? Is that a correct assessment? Yes, thank you for your honesty. Honesty. Is that a correct assessment? That you guys don't like to work too much? Guys, I want you to do page 491. Please stop talking. I'm not done. And when you talk, you're being rude. 491. I want you to do numbers 2, 8, and 9. Think about number 10. You could totally do number 10 without me taking you step by step through that. Think about it and don't come back here and say, I don't know what to do. Do it. Number 12. Suck it up and do it. Yeah, she did. You sneaky dog. I deserve some extra credit points. Thank you very much. Nope. How about this? La 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 la. Yeah, let's do 32.